So we continue with reduction. So now we're doing that was question 5. We're now doing question 6. Now, what was the answer for I6? So I didn't try. I hope you just realized it wasn't that. Okay, so for this one, remember we did, we integrated x squared sin x dx. So here is a special case when n was equal to 2. So now let's see the general one. So we still let u to be equal to x to the power n, and then du is going to be n x n minus 1, dv sin x dx, and then v will be negative cos x. So we're saying this integral here is equal to negative xn cos x minus the integral. Now, so now, okay, let me just write it the way it is. N x n minus 1 and then negative cos x. This one is one that comes with dx. So I'll put dx here. So we just brand it. This is this. Then plus, we take n outside. Then we have x n minus 1 cos x dx. Now, the other one, the previous question that we are doing, when we reached here, we had everything inside here apart from the n minus 1 here was appearing here. But now look, we have cos and here there is sine. So we can't say we have found the reduction formula. We need sine here. So what do? We use by parts again here. So we continue and say, okay, let u now be x n minus 1 so that du becomes n minus 1 x n minus 2. dv is cos x dx. Then v is positive sin x dx. Like that. Then we're now talking about x n minus 1 cos x dx. This is equal to x n minus 1 sin x minus the integral of n minus 1 x n minus 2 sin x dx. We go and substitute now in in. So we'll have negative x n cos x plus n open x n minus 1 sin x minus the integral of n minus 1 x n minus 2 sine x dx. Then now we expand, so we have negative x n cos x plus n x n minus 1 sine x minus n, this n from here. Then this n, we take it outside the integral, is just a constant. And then we remain with the integral of x n minus 2 sine x dx. Of course, here there's a condition that when n is greater than 2, simply because anyway, greater or equal to, I think, just for a formula to make sense. Because if it's 1, then you don't need to get this far. But for 2, we can, there's no problem. So we now compare. The initial question has xn sine x dx, and it is named after the n that is on x. So we follow the n that is on x. So here we now have n minus 2 on x, but the sine x dx is also here, meaning that we can easily name this one. So we're saying in is equal to negative x to the power n cos x plus n x n minus 1 sine x minus n minus 1 I n minus 2. So it means we have found the reduction formula. Yeah. Once we are able to name the inside and the n reduces, then that is a reduction formula. And here we are finding when n is equal to what? And then check when n is when n is equal to 6. Oh, and this one, okay, we've done the general one. So we've done the general one, but look at the question. The question is saying for 0 up to pi over 2 x to the power n sine x dx, and then I6. So if he asks in this form, what do we do then? So in our general formula first, before we start attempting I6, in our general formula first, we must find the whole integral from 0 to pi over 2. So that what remains is just substituting the 6. So we do from 0 to pi over 2. So from 0 to pi over 2, so we're now saying we want to do I n from 0 to pi over 2. So where there is x, also we're taking 0 and pi over 2. So we'll start with negative pi over 2 power n cos pi over 2 minus negative 0. So here I think let's just leave it just 0. So the minus 0 part will leave it. Also still get 0. But there's x there. So we move to plus. So plus n pi over 2 power n minus 1. And then sine pi over 2, that is 1. Sine 90 is 1. So let's write it, sine pi over 2. And then minus n minus 1, n minus 2. But funny enough, this guy is plus 90 is 0. So it's like we just have n pi over 2, n minus 1, and then that is 1. So minus n minus 1, I n minus 2. So this is the formula, the reduction formula. Specifically from 0 to pi over 2. Very simplifying. But now I want to find I6. So to find I6, we target I6 now. So we have 6 pi over 2 power 5 minus 6, 5, and then I6 minus 2, that will be I4. Then we find I4. So what is I4? I4, we substitute in this very one. It will be 4 pi over 2 power 3 minus 4, 3 I2. So that will be 4 minus 2. And then now you find I2. So it will be 2 pi over 2 minus 2 by 1. And then I0. So if we go back and check I0, what does I0 do? It just disappears the x, but the sin x remains. So we don't just rule out the I0. I0 is found manually. So we have x to the power 0, and then sin x dx. So the integral of sin x is negative cos x. So it's like here we're dealing with pi minus 2, and then negative cos pi over 2 minus negative cos 0. Remember, we have 0 down, so this becomes pi. This is cos 90 is 0, so this is 0 here. So we have minus minus, which is plus, so it remains minus 2 because cos 0 is 1. So this is I2. So we substitute there, we substitute here. Nicely. Let me try to change the ink. So I6 is going to be 6 pi over 2 power 5 minus 30 open 4 pi over 2 3 minus 12 I2 is pi minus 2 plus C, which is the numbers are small, so we can do that is 32. So 6 over 32 is 3 over 16 I5 because 2 power 5 I think is 32. Then 2 into 6 is 3. 2 into 32 gets 16. And then minus that is 2 to the power 3, that is 8. 4 into 8 is 2. 2 into 30 is 15. So I get 15 pi 3. Then plus 30 by 12. 30 by 12. 360. So plus 360 pi. And then 12 by 2, that is positive 24. Positive 24 times negative 30. That is minus 720. Yeah, minus 720 plus C. The users of electromagnetic Formulae and Steve Paddy. So when you're studying, this is what you do. Okay. After I find the reduction formula, after I reach it here, you realize that the question is demanding for the integral because the question we're answering is which question I answer? Is here. We're answering this question. Yeah. From 0 to pi over 2, xn sin x dx. And then we want to find the value when n is equal to 6. So what's the integral? When you have x to the power 6 sin x dx from 0 to pi over 2. So what do? We now attend to the pi over 2 issue, 0 to pi over 2 in the reduction formula. So you say, okay, we'll take, before we can go to I6, in the very formula here, we substitute 0 to pi over 2. Now, when you do that, you realize that when you take pi over 2 in the formula here, where there is cos, You put pi over 2 here. Pi over 2 for cos. Cos 90 is 0, so this becomes 0. If you put 0 here where there is x, you're now dealing with 0 power n cos 0. This is 1, but there's 0 outside. So this whole part disappears. When you put 0 here, it disappears. When you put 90, sin 90 is 1. So this part remains. That's what we have here. And then you move to the next one. We have no space to put 90 here or to put 0. So we'll leave it. When it's needed, we'll come and put it. So now the reduction formula has ended up being this one. So all we need is just to put n here. You put n, 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 n once the n is given. Given that n is 6, where there is n here, you put 6. Where there is n, we put 6. 6 minus 1, we get 5. 6, 5. So we have 6, 5. And then I, 4 minus 2. 6 minus 2, we get 4. So now this is done. We now get I4. So we do I4. When you say I4, you go back to the original IN. Where there is n, you put 4. So we have 4. 4 minus 1, 3. 4 minus 1, 3. 4 minus 2, 2. You have found this one. Remember, this is being multiplied by 30 when we need it. Then we now find I2. I2. We go back to the original one. This was saying greater or equal to 2. So the original one, you put 2 here, 2 here. So we have 2 pi over 2 to the power 1 minus 2. 2 minus 1, we get 1. And then I, 2 minus 2, that is 0. But when it is I0, don't just ignore this is 0. When it is I0, you get 0 and take it in here, in the original. So this will be 0. So x to the power 0 is 1. So you remain with sin x dx. Then integrate this. It will be negative cos x. That's why we have negative cos x here. Then we have limits from 0 to pi over 2. So we start with pi over 2 minus the very thing with the angle 0 now. Cos pi over 2, this is cos 90, it is 0. So we get 0 there. Then we have minus, minus, making it plus inside. Cos 0 is 1. So positive 1 times negative 2, we get negative 2. So the whole I2 has reduced it to pi minus 2. So pi minus 2 now is I2. Then we go back to I6 and substitute I4. As we substitute I4, so we'll say 6 pi over 2, 5 minus, this is just 30. 30 I4, but we know what I4 is. I4 is 4 pi over 2, 3 minus 12 I2. But I2 is just pi minus 2. So we substitute pi minus 2 and close. Then we start expanding this one now. So this one is fixed, but as we fix, we realize that 2 to the power 5 is just 32. So this is 6 over 32 now. 2 into 6 goes 3 times. 2 into 32, 16 pi 5 minus. This is 8 outside. This is 4 inside. But 2 to the power 3 is 8. 4 over 8 is half. That half, the 2 into 30, 15. This whole thing reduces to 15 pi 3. Then negative, negative, we have positive. 12 times 30, found 360. 360 pi. Yeah. Good. Then next, we move to this one here. Negative 12 times 2 times negative 2, it becomes positive 24. Positive 24 times 30, negative 30 becomes negative 720. Then plus the constant c. The secret is on getting here. Because if you avoid this, thinking you make mistakes, your I6 is going to be very long here. It will be long because nothing will vanish. Realizing that you have limits from 0 to pi over 2 helps us to have some parts vanish. We just remain with the important ones. So let's go to the other one, number 8. The seventh question here, which is C in the tutorial sheet of under that question for reduction. Excuse. So we go to question. We go to C. C, that is IN is equal to the integral sine n x dx. This is the same thing as sine x to the power n dx. So this one, it's about sine. So we play a bit of some simple math here. N is supposed to be greater or equal to 2 again on this question. So what you do is, sine works so with cos. Now making it stand alone, we must know that no matter what we do, cos will come in. So you prepare for cos. But when cos comes, it must find this in a special way that won't have difficulty. So what we do is we just temper a bit with the n, maybe reduce it by 1 so that we have n minus 1 here. Without throwing away that sign, that 1 will multiply by sine here. This is like 1 now. So sine x to the power 1. Then we'll say, okay, now we can go to our by parts. Let u be the complicated one. Sine x to the power n minus 1. And let dv be sine x, which is not complicated, dx. And then integrate this, we'll get negative cos x. Because we knew cos x was coming, so negative cos x. And then du, we now drop n minus 1 sine x, that is sine n minus 2 x. And then the derivative of sine x inside is cos x. So we'll now write our in as uv, that is negative cos x sine n minus 1 x. And then we'll do that. So remember that when we are doing this, if we want, we can name it n minus 1 here because of tempered with our with our original in. Tempered with it a bit. So we have that. Okay, let's not rename it so that we keep the same that we've been doing on others. So keep it like that, then minus. So I'll put plus because of this minus that is here. So plus, and then I'll leave the n minus 1 outside. This n minus 1 and the du. And then inside, I'll have sine n minus 2 x. Then this is cos x and this is cos x. So I'll have cos squared x. And then dx. Then this is negative cos x. And then sine n minus 1x plus n minus 1. Remember, cos squared is like 1 minus sine squared. So write it in that form. So we have sine n minus 2x, and then open 1 minus sine squared x dx. So this is negative cos x sine n minus 1x plus n minus 1, and then the integral we expand, that is sine n minus 2x, and then a dx minus n minus 1, and then expanding the integral of sine n, because this is 2 here. So when we add the powers, so we have n x dx. Okay, remember, we didn't temper with this one, said we just leave it like that. So it is in. But it seems like the in has come back inside here. So I have no problem with that. So we just say in. So just, this is minus. So bring the other side as plus. Say plus n in minus in is equal to negative cos x sine n minus 1x plus n minus 1. So because everything, sine is here, x is here, dx is here, sine x dx. Only the n part has changed, it has gone to n minus 2. So this one can carry the name I n minus 2. Like that. But this one and this one will cancel. So we remain with in is equal to negative 1 over n cos x sine n minus 1 x plus n minus 1 over n in minus 2. So this is the reduction formula for sine n of that kind. When n is greater or equal to, let's try it at the, the integral of, if they ask you to integrate sine x or sine squared x dx, what do you do? We first change it to that form of cos. What is even the form of cos? The half. So we say 1 minus cos 2x over 2 integral of dx. That's how we write the sine squared. Then you can take the half outside and integrate the first one to get x. Then the second one, the integral is a minus sine at 2x, so it will be over 4 plus c. That's how the integral comes out. So now if we are to place this one here, I2, let's see how it's going to be. We'll have like negative 1 over 2 cos x, and then cos 2 minus 1, that is sin x, and then plus 2 minus 1, that is 1 over 2, and then I0. I0 meaning sin, so it will be just like 1, so this would just be x, like this. But you know, this one is the same thing as what you found there, because remember that sin 2x, the same thing as 2 sin x plus x. So if we we went back there, I would say this is like negative 1 over 2. And then because we just have sin x cos x, so we'd write sin 2x over 2. And then plus half x plus c, which is just same thing as half x minus sin 2x over 4 plus c. So if we are doing I2, you leave it here. Whatever I was doing here was just to show you that these two are actually equal. So if you don't know the reduction formula and you have forgotten that you can change sine squared to this double angle identity, it means that you're in problems. But if you know the reduction formula, such things is just a bonus. You just write the formula itself and then plug in the small numbers and it comes out. So your task now is to answer it directly where it is in the question. Okay, so in a minute, that is remaining, we run through. So we have sine to the power nx dx. Because we know it's sine, if we use 1 here as our dx, then we have issues because integrating sine, no matter what, at some point, whether we differentiate or integrate, it will involve cos. So we prepare ourselves that when cos comes, it must come as cos squared, so that we are able to change it back to sine, especially in the integral here. So how do we do that? We separate here. Instead of dealing with sine x, we deal with sine x n minus 1 multiplied by sine x dx. That's why we have this split here. U sine x n minus 1 dv sine x. Then you integrate, and then your in becomes this whole thing here. Then now you change cos squared to 1 minus sine squared. Then you split. Now because I've split like this, then this part sine n is what we have as a question, which is named the in. So we take it the other side where there is in. And you see something canceling here, this one remains. Then you divide by n so that you remain in the formula for in until you have this thing. So your task is to finish up on the I mentioned in the tutorial sheet, those numbers there. I don't know if it's 6 and 7.